Okay, and we are back at it again, better than ever. 10-minute math review, exponential functions. What is going on? Let's see what we got cooking in the math oven today. So we got exponential functions written in the form of y equals a to the x. That's what they look like, where a is going to be a constant value. So we got two examples here that I dug up for you. So I got y equal 2 to the power of x. Couple things to note about this graph. Basically, as x gets bigger, so does the graph. So y values also get bigger. We typically call this an increasing function. And you'll notice a couple characteristics that we'll go over afterwards, but we have a y-intercept here at y equal 1, and we also have a horizontal asymptote right here at, whoa, that's terrible. But that's at y equals 0, so what I'm trying to do there. I can't really see my screen right now. There we go. Okay, here's another example of what we call a decreasing function, and this is y equal negative 2 to the power of x. So you're still going to see the same y-intercept of 0, 1, and we still have this horizontal asymptote here that goes right there at y equals 0. I'm going to just try to do a straight line this time. Better than last time. It's not perfect, but nothing in life is. So basically, anytime you got your a value between 0 and 1, as your x value increases, your y value decreases, and you get kind of this decreasing pattern. So a couple properties to note on these bad boys. So there is a horizontal asymptote at y equals 0. The y-intercept is always going to be at the point 0, 1. And just note the shape of the graph depending on the value of a. So when we had a positive a value that was bigger than 1, we had this graph that we called increasing. And then when it was less than, or rather between 0 and 1, you got this decreasing pattern seen here. And yeah, the range of these graphs is going to be x element of the reals, and that's the domain, and the range is going to be y greater than 0. So let's take a peek here and see what we can do. Let's do another graph. So we're going to try to graph y equal 3 to the x and just see what that looks like. So a couple things, like we already know the y-intercept is going to be at the point 0, 1. I will include it in my table of values here. So what I recommend you do is you make a little table of values. It doesn't have to be anything fancy or complicated, but you grab a couple points like negative 1, 0, and 1, and you see what happens. So when you plug in x equals negative 1, what's going to happen is you're going to have y equal 3 to the negative 1. Well, when you do the reciprocal, because that's what the negative exponent does, that gives you 1/3 for y. So you're going to get 1/3 over here. That is a 3. When you plug in x equals 0, you're going to get 3 to the power of 0, and that is the value 1. So that is our y-intercept that we said we would have before. And when you plug in when you plug in x equal 1, you're going to get 3 to the 1, which gives you 3. So when you start popping these points in, so we can draw the horizontal asymptote here as such. It's not my best work, but it will do. So there is y equals 0 horizontal asymptote. Just starting with x equal negative 1, we get 1/3. So we're going to sort of pop that point right here, and we'll label it after. Then we have the point 0 for x and 1 for y. So that's the point right there. And then we get the point 1, 3. So I know from my theory that this is going to be an increasing function. So I know it's going to sort of go, like this. Whee! Goes up fast, and then as x gets smaller and smaller, it's going to want to hug that asymptote. Again, not my best work. I'm just getting used to my new writing pad here, so doing my best to do that. But there it is, y equal 3 to the power of x. So not a huge difference when you compare it to, say, the one we had before, but there it is. You need those points. I promised that we would label that point, so we should write negative 1 and 1/3, and we are good to go. That would be good enough on the grade 12 pre-calc exam. Let's take a look at an a value that is between 0 and 1. So we know that these ones are called decreasing graphs, and they have generally this shape. We know a couple things about the horizontal asymptote at y equals 0. So I'm going to say, let's just get that out of the way. And as you can tell, I'm getting much better already at getting straight lines on my drawing pad. So again, I recommend make a little table of values. Try not to make it as sideways as mine, and plug in maybe negative 1, 0, and 1, and give yourself some room to work. So when we plug in negative 1, this is going to be interesting because you have 1/2 raised to the power of negative 1. Well, you do the reciprocal when you have a negative exponent, so you flip a half, and you're going to get 2 over 1 to the 1, which is really just 2. So that gives us the point negative 1 2 right there. Then you plug in the point x equals 0. Well, anything to the power of 0 is 1. So that is our trusty y-intercept at 0, 1. And when you plug in the point y or x equal 1, you're going to get 1/2 to the power of 1. So when x is 1, y is 1/2. So you can already see that we're getting closer to that asymptote. So we're going to want to go and hug the asymptote like that. That's not bad. And then just kind of pop up like that. That would be good enough for a sketch. So we kind of lost that point. Probably using a pen that's a bit too thick. But we got the point -1, -2, or -1 for x and 2 for y. 0, 1, and then 1 and 1/2. So there it is, a graph of a decreasing function. So I went ahead and I kind of grabbed 2 questions from 2 exams. This is a June 2019 exam question, and it's a 3-marker, so a bit more on the heavy side. And what they got here is they've given us the graph of y equal 4 to the x. So they have the horizontal asymptote, and they have y equal 4 to the x. So we'll notice the point 0, 1, and the point 1 for x has a value of 4 for y. That's easy enough to calculate, and that's all they give us. And then they say, well, based on this graph, can you sketch this transformed graph where we have y equal 2 times 4 to the power of x minus 3 as the exponent, and then plus 1. So basically what I would do is say use your knowledge of transformations here. So that xy point on the original graph, which I suppose we can make a little table of values here. So let's go ahead and we'll also grab it -1. So when x is -1, on the original graph, you would get 1/4 for y. So that might be handy to use, it might not be, we'll see. Then we get the point 0, 1, and then we get the point 1, 4. So what's happening to those points on the new graph? Well, let's take a look at our function. So if you look at this 2, that's going to be multiplying the y value. So all our y values are now getting multiplied by 2. So we're getting 2 times y. This plus 1 means we're adding 1 to the y values. So there, that's what's happening to my y values. On my x values, I'm going to look at my exponent. So you got to remember that the sign is always the opposite. So I have x minus 3. It's actually going to end up being x plus 3. And that's what's going to happen. So now I'm going to take these 2 easy points and transform them and see if I have enough to get a sketch. So the point 0 is going to go 0 plus 3, so I'm going to get 3. Then 1 times 2 is 2 plus 1 is 3. So that's a new point. And then the point 1 plus 3 gives me 4. And then 4 times 2 is 8 plus 1 is 9. So that's another point. We also need to consider the horizontal asymptote. So we got our horizontal asymptote y equals 0. And we got to do the transformation to it. So the x value doesn't matter, but the y values do because it's a horizontal asymptote. So 2 times 0 is 0, plus 1 gives me a new horizontal asymptote at y equals 1. So I'm going to go and do that one, and I'm going to do my best to do a straight line. Remember, I am using a new writing pad. So I'll get better at this, but that's pretty decent. So that's y equal 1, new horizontal asymptote. And then we had the point 3, 3. So I'll count up to 3 for x and 3 for y. And then I had the point 4, 9, which would be up here. No need to label them because they are nice and on the grid. And then I need to think like, well, the general shape of this is going to be the same. I could transform this point to get another one. You know, I just don't think it's going to be worth it. I don't think we need it. Like, we know it's going to cross, the y-axis, and it's going to want to hug that asymptote. We could easily find the y-intercept, so it might be worthwhile to go x equals 0, pop it in here and get the y-intercept. So let's quickly do that, see if we get a nice value. I don't think we're gonna. We would have 2 times 4 to the power of -3 plus 1. So that's going to be an ugly value, so they're not going to necessarily expect it for 3 marks. For 3 marks, they're going to be looking for the general shape and whether or not you got the vertical translation and the horizontal translation. So we have all that. So let's just go ahead and just kind of do that. We know we're going to hug the asymptote, and then we're going to want to go up and we're going to hug that point. Going to make those really big and exaggerated there. So there's the new function, and that would be enough to get 3 out of 3 on the exam. So that's a particularly tricky question. I got one more here. So this one is from the January 2018, and it's just a 2-marker. So basically what they've done is they've taken y equal 1/2 to the x, and we've done one transformation on it. So we already know that in general, y equal 1/2 to the x, I believe that we graphed this one, didn't we? Let's go take a trip down memory lane for a second here. We did, we graphed this exact one. So this is what it looks like. And that's fine. We're going to be shifting the x values 1 unit to the right. So any xy point on this graph is going to become x plus 1 comma y. So it'll be easy to do because we know that, well, when x is 0, y is 1. When x is 1 on the original graph, I'm thinking here, we would get a half for y, which is kind of an inconvenient point to transform maybe. And when x is negative 1, we would get the value 2 for y. We also know that our horizontal asymptote is going to be right here. And that's not going to change because we're not doing any transformations to the y value. So that's going to be y equals 0. And I can happily go and do these transformations. So this one, 0 plus 1 is 1. So we're going to have the point 1, 1. And we're going to have the point, 1 plus 1 is 2. So we're going to have the point 2 comma and a half. And we're going to have the point negative 1 plus 1, which is 0 comma 2. Now this is the y-intercept, so it's a nice value, so they'll be expecting you to do it. And what else? So we got 0, 2 plotted. The point x equals 2 and y is a half, so that's kind of right here. And then we also got the point x is 1, y is 1, so boom. Now we know that the general shape of this is a decreasing function, so we're going to be looking for that shape. So let's go ahead and just go like this, and then let's go and hug that asymptote. Not bad. Perfect. And we are done. That is it. I hope you enjoyed this installment of 10-Minute Math. Have a good one. Bye-bye.